Hello guys, welcome to our video of the playlist called C# for Beginners. Okay, so we've been using strings since basically lesson 1 of this series, printing them, concatenating them, interpolating them. But strings actually come with a whole toolbox of built-in methods for cleaning, searching, splitting, and formatting text, and honestly, most beginners only ever scratch the surface of what's available. Today we're gonna dip into toolbox. Let's say we are building something like that, the process or program that processes user input like a sign up form. Let's see that, for example, string and then maybe user input equals, for example, John do email.com, like this, something like that. Here's a pretty realistic piece of messy user input, extra spaces at the start and end, inconsistent capitalization. If you tried to use exactly as is, comparing it against a stored email, it would almost certainly fail to match, even though it's really the same address. This is exactly the kind of problem today's methods solve: cleaning, transforming, and working with text safely. Let's go through them one by one. Let's start with capitalization, since that's the part of our messy example above. A sample email with inconsistent casing, yes? Now we're gonna try string lower equals, maybe we can call it, let's see, another input, string email equals, for example, this time only with capitalization, John do email.com. Yep, string lower equals email dot to lower. Oops, to lower. Yep. Email dot to lower converts the entire string to lowercase and stores it in a new variable called lower. Okay. So let's see the output. I think you are seeing the terminal. Yep. .NET run. Oops. John Doe email. Printing out, we get the fully lowercase version, right? And see the uppercase version also. Is that string upper email dot to upper. Console dot write line upper. And do up dot upper does the exact opposite. Everything becomes uppercase. Yes. Let me show you the real example why these kind of things matter. String, for example, stored email. Yep. John Doe dot email dot com. Email.com. And then maybe string typed email. Here's exactly why this matters. Comparing two emails that are logically the same but typed with different casing. Yes, by converting both to lowercase before comparing them, we get a match even though the original strings look different. Yep. And let's show the output. as you can see, it's true, but if you look at here, they are literally different, but they didn't intend that, so they want to access this email, so we are kind of comparing with using lowercase and whenever we need the uppercase. Okay, so to uppercase and to lower, don't change the original string. Remember, strings are immutable in C#, so these always return a brand new string, genuinely essential for any kind of case incentive comparison. Okay. Next problem from our messy input, those extra spaces at the start and the end. Remember, let me show you. String messy input equals, for example, John Doe. Like that, yep. Notice the space surrounding the actual name, yep. So we're gonna use our new method here, string TrimEnd equals messy input dot trim. console.writeLine here trim it. Okay. Messy input dot trim removes the white spaces from both the beginning and end, but leaves anything in the middle untouched. Printing it, wrap it in quotes here, so we can actually see the spaces gone. Let me show you what was the output. As you can see, John Doe, and we are not seeing any space after this kind of quotes. Yes, so let's see without this trim method. Let's see that. Let's see input. I'm doing this because to show you the difference after trim it. As you can see, inside the quotes, you can see the space. That's the problem that we eliminated using trim function that is built-in function for strings. Yep, got that? Yep. So now let me show you some another examples of trim. Yep. Trim and here we can comment them out. For example, we can say string trim start only, trim start only equals messy input dot trim start. Yep. And string trim messy input dot trim end. Yeah, and if you only want to remove the white space from one side, there's a trim start and trim end specifically for that. Let me show you the outputs here. Oh, actually, you need to output this console.writeLine. Trim start. Trim end only. Yep. John Doe and John Doe. As you can see, here's the space. Let me show you. As you can see, there's a space after that and before that. Using the trim start only, we just deleted the space that was unintentional by trim start, but after the string, the blank space just left. With using the trim end, we just deleted the end part of the spaces that we didn't put, that we didn't want to put. Okay. So trim is genuinely one of the most commonly used string methods in real applications. Anytime you're accepting user input from a text box, a file, anywhere, trimming it first avoids a whole category of subtle matching bugs. Now let's say we want to extract just a part of string, like pulling out someone's area code from a phone number or something like that. Yes. So let's see example string, maybe phone number. Yes, and 555, maybe 1 2 3 and 4 5 6 7. Yep, and a sample phone number, and we are just area code. equals phone number dot substring 0 and 3 console dot writeLine area code. Phone number dot substring 0 and 3, the first number is where to start, index 0. Remember, strings are 0 indexes just like arrays, and the second number, that is 3, is how many characters to grab. So this grabs 3 characters starting at position 0. And let me show one example. Let me show the output result of that first. As you can see, it's 555. We are taking the 3 elements starting from the 0 index. And let me show you another example. String rest of number equals phone number dot substring 4 console rest of number. And if you only give it one number, no length, it grabs everything from that starting position all the way to the end of the string. So let's see the output, what I mean here. As you can see, it's getting all of the numbers from the fourth position until the end. So it just shows the starting index, and the ending index would be just kind of end of the string, okay? And common problems with this kind of examples, let me show you one example. For example, if there's string, maybe short string equals maybe high, yes, and some people may try sometimes something like that, maybe broken equals short string dot substring maybe 10 0 10 maybe 0 10. Here's a genius gotcha. If you ask for more characters than actually exist in the string, this crashes. Something worth being careful about, especially with real unpredictable user input. Okay, substring let us extract exactly the piece of text we need by position. Really useful for parsing structured text like phone numbers, codes, or IDs, or whenever you need this kind of catching some kind of parts of the string. So next, what if we need to swap out part of a string entirely? Let me show you example. String sentence equals maybe I love cats. Cats are great, maybe. Great, yes. A sentence mentioning a cats twice, right? And string updated equals sentence dot replace cats dogs console dot writeLine updated. Sentence dot replace cats dogs replaces every occurrence of the first string with the second. So let me show you the output. As you can see, I love dogs. Cats are great. Why? Because here cats are uppercase. So let's make it cats just, and then let's run it. I love dogs. Dogs are great. Notice something important here. Replace is a case sensitive by default, so cats with capital C did not get touched, only the lowercase one. Worth combining with ToLower first if you need a case insensitive replace, okay? Now, one of the genuinely most useful string methods, breaking a single string apart into multiple pieces. Let me show an example. String, maybe CSV lines. Do you know the CSV files? It's kind of example like that. Alex, maybe 25, and then engineer. Yes. single life of common separated data, CSV, like you might read from a CSV file, yes. And let's see how we can use our next useful function. Parts CSV line dot split, and then we're gonna say here, okay, CSV dot split comma, this breaks the string apart wherever it finds that character, namely the comma, and gives us back an array of these pieces. So let's see the output for each string p in parts console dot write line p. Okay, Alex 25 and engineer. Looping through, we got three separate pieces: the name, age, and the job title. And let me show you much more comprehensive example. Maybe string. Oops, I think we need this one. Oh, why yes. Yep. Just comment out this one, and you're gonna say string name and parts, maybe zeros, and int integer int dot parse parts first element, and string job equals maybe parts 2. Okay, and console dot write line name is age and works as job. And here's a really common pattern: split the line apart, then grab each piece by index, converting to the right type as needed, like parsing that age back into an int, right? Split is genuinely essential for parsing any kind of delimited text, CSV files, URLs, comment arguments. All of it relies on this, okay? So it's worth learning deeply and very well. And naturally, if split breaks a string apart, there should be something that does the opposite, puts pieces back together. That's join. Let me show you. Before that, let's see the output, okay? As you can see, Alex is 25 and works as an engineer. Done. And maybe there's a string words equals maybe C# is genuinely fun. C# is an array of separate words, right? String sentence equals string dot join, and then we're gonna have put space and then words. So console dot write line sentence string dot join space words. Notice this one's called differently, directly on string type itself, not a specific string variable. The first argument is the separator to place between each piece, and the second is the collection you want to join together. So let's see the output. As you can see, C# is genuinely fun. So what if I put here a comma? Let's see the output. As you can see, C# comma is comma genuinely comma and fun. That means the first argument is the kind of string that we want to add between the parts of this array. Okay, array of strings. So let me show you the example with lists also. Okay, maybe lists of string, maybe tags equal new list string, and what kind of maybe C# and .NET tutorial, okay, and string hashtag line equals string dot join, maybe this one, and then tags console dot writeLine hashtag line. And it works with lists too, not just the arrays. Genuinely handy for building things like a comma separated tagline, exactly like what we've been putting in our video description this whole series, right? Or any other website like Instagram, whether you see the hashtag, something like that. Okay, let's see the output. As you can see, C#.NET tutorial, like that. And you can put something like that here also. It works actually very good. C#.NET tutorial, okay. Split and join are basically mirror images of each other. One breaks apart and one puts back together, both built around a chosen separator. Now let's talk about searching inside a string, checking if something exists, and if so, exactly where. Let me show you the example, maybe string message, and on message, please contact support for help. Sample message, right? And bool has support equals message dot contains support, right? And console dot writeLine has support. Message dot contains support. That's a simple yes or no check. Does this text exist anywhere inside the string? Okay, so let's see the output. True, yes. Why? Because you have the support word exactly in the string variable called message. And let's see the example with integer also, okay? Int position, to get the position of exactly where our the string that we want to find, exactly what kind of index it's staying, the variable we are searching from, equal message dot index of, and then support. Okay, so let's see output also. Position. Okay, 15, yes. IndexOf goes a step further. Instead of just say yes or no, it tells us the exact position where that exact the text starts. Okay, exactly the text starts. In this case, support begins at the index 15. What happens? It's not found. That's a really interesting case. So let's see that. Maybe we're gonna say int not found equals message dot index of maybe billing. Okay, console dot writeLine not found. -1, right? And if the text genuinely is not found anywhere, IndexOf does not crash, it just returns -1. This is actually a really common pattern worth remembering. -1 specifically means not found, so you'll often see the code checking if position not equal to -1 before using the result. Contains for a simple yes or no, and IndexOf you actually need to know exactly where in the string something is located, okay? And the next thing is two more quick, genuinely useful checks specifically for the beginning or the end of a string. Let me show you. For example, string, maybe file name, report final dot pdf, right? Sample file name, and bool is pdf equals file name oops, file name dot EndsWith dot PDF console dot writeLine is PDF. Okay. File.endsWith.pdf checks that specifically if the string ends with the exact text. So let's see the output. True. Why? Because our string is ending with exactly .pdf. And let's see other example. Bool is report. File name dot starts with maybe report console.writeLine starts with is report. Yep. Oh. True. And starts with does the same thing but checks the beginning instead. Okay, both of them are genuinely common for things like validating file extensions or checking URL prefixes, like whether a link starts with HTTPS or something like it. Okay, now we've technically been comparing strings with the whole series with the equal sign, right? But there's a bit more nuance worth understanding here. Let me show you why you should be more careful when comparing strings. A equals hello, string B equals hello, right? And console.writeLine A equal B. Okay. Direct equality with double equals is a case sensitive by default. Hello with capital 1 and hello with the lower case are considered different. So let's see the output to prove that, and it's false. Yes, because they are that's case sensitive when we use the equal sign. And let's see another example. Okay, here bool r equal ignoring case maybe equals string dot equals a b string comparison dot ordinal ignore case, right? And here let's comment out console.writeLine r, yep, string dot equals a and b string comparison dot ordinal ignoral case. This is a more explicit, more controllable way to compare, and passing ordinal ignoral case tells it specifically to ignore case differences. So that means the r equal ignoring case should be true in our case. Let's prove that. Yes, it's true, because we are saying explicitly to just ignore the case sensitivity here. And let's see one more specific part. Int comparison equals string dot compare string a b string comparison dot ordinal ignore case. Okay, console dot writeLine comparison, right? And string.compare goes even further. Instead of just one true or false, it returns a number. 0 means equal. A negative number means the first string comes before the second alphabetically, and a positive number means it comes after. So let's see the output. Console. Let me comment this one. Okay, 0, because they are equal. Let's see, maybe some kind of something like that. Negative value, because this one comes before the A value, comes before the B in terms of alphabet. So what if we put some kind of maybe T value and then see the output? I think that should be positive. Yes, positive, because we are starting from T, and T is much more further in the alphabetical term after H. Yep. For most everyday comparisons, equal sign or ToLower comparison we saw earlier are perfectly fine, but when you need a more control, especially around the case sensitivity, string.equals and string.compare with an explicit string comparison, this kind of enum class, I think, are the more precise professional tools. Okay. Alright, let's talk about formatting numbers and dates inside strings, something that comes up constantly in real applications like displaying prices or percentages. Let me show you example. For example, we have double price equals 19.5, right? And string formatted equals price dot to string console dot writeLine formatted. Price dot to string and C, that C stands for currency. It automatically formats the number as money, adding the dollar sign and making sure there's always two decimal places. Let's see the output. As you can see, there's a dollar sign, and also here in the example, in the code we wrote a price that's 19.5, but here as you can see it's 15, right? Let me show you other examples with that also. Double maybe percentage equals 0.56 string percent formatted equals percentage dot to string and P. Okay, and we're gonna here console.writeLine percentage formatted. Let's see the output. As you can see, 75.60%. P stands for percentage. It multiplies by 100 and adds the percentage sign automatically. Now remember string interpolation from way back in lesson 2, I think. These format specifiers actually work directly inside the interpolated strings too. Let me show what I mean here. Console.writeLine, this sign, and then here, okay, price, and then maybe, actually, why delete that price? I need the price. Console.writeLine, price, C, console.writeLine, discount, maybe percentage P. Notice the colon right after the variable name inside the curly braces, price colon C and percentage colon P, same formatting, just written directly in line, which is genuinely how you'll use this most of the time. So let's see the output, how it's gonna change. As you can see, it's price with the dollar sign and also with two number precision, and also percentage with percent sign and in correct format. See that inside the interpolation mark we can use with columns the C and P sign to convert in a much more understandable way in strings. Okay, and one more genuinely useful specifier is with pi. Let me show you. For example, double pi I think it's gonna start from 3.14 and maybe 15 and some kind of values, right? And console.writeLine pi rounded pi pi and here f2 f followed by a number controls decimal places. Specifically, f2 here rounds to exactly 2 decimal places, genuinely useful whenever you want to control precision without doing manual rounding math. So what I mean here, if we run this code now, we only see 2 points after the 3, right? And it would be 3.14. So what if we do it something like f5? I think we're gonna see in this time 5 numbers after that, right? So that's very useful thing whenever you are doing the kind of calculation things in a projects based on math or something like that. That would be useful to know, right? Format specifiers combined with interpolation are how you turn raw numbers into properly formatted presentable text. Money, percentages, rounded decimals, all without writing manual formatting logic yourself, right? Okay, last concept for today, and this one addresses a problem you might not have even noticed yet. Let's build a string gradually, piece by piece, the way we normally would. For example, string result equals maybe just empty string, and for int I equals 0, I less than 5, and I plus plus. Okay, and result plus equal item I. Okay, console.writeLine result. A loop building up a string using plus equal each time, this works completely fine, and for something small like this 5 items there's a genuinely no issue, right? Let me show you. Item 0, item 1, item 2, item 3, and item 4, right? But here's the thing worth understanding. Remember, strings are immutable in C#. Every single time we do result plus equals, C# is not actually modifying the existing string, it's creating a brand new one, copying everything over and throwing the old one away. For five items, that's not a big deal. But imagine doing this 10,000 times inside a big loop. That's 1,000 new strings being created and discarded, and it genuinely starts to hurt performance. That's exactly the problem StringBuilder method or function solves. Let me show using the example. First, we need to call using system.text. It leaves StringBuilder lives in a different namespace than what we normally use. Okay, and we're gonna initialize here StringBuilder StringBuilder new StringBuilder, like here. What's the problem here? Just var. Yes, system.text. Okay, string.builder, right? String builder and builder equals new string builder, creating a new empty builder, right? It's a class, so we are initializing our class and creating instance of our class. And int I equals 0 and I less than 5, I plus plus builder dot append item I. Okay. Builder.append inside our loop, unlike plus equals on a regular string, append actually modifies the builder directly in place, no new string being created and thrown away each time. And let me show you the final result. String final result would be builder dot toString console dot writeLine final result. Item 0, item 1, item 2, and just fine, right? And once we are done appending everything, we call builder.string to convert it into a regular normal string we can actually use and print. For small one of string building, regular plus equal is completely fine, but genuinely don't overthink it, okay? But the moment you are building a string inside a loop that could run many times, StringBuilder is the properly efficient tool for the job, right? Alright, let's close this out by combining a bunch of what we've covered today into one realistic example, cleaning and formatting a batch of user signed app data. Okay, let me show you. Let's just close the terminal for now. Maybe we have array of strings, row entries we call it. We're gonna have some kind of messy data. Alex 29 Alex email.com. Maybe space here also. And Sam, Sam 34, maybe Sam email.com. Okay, just 2 is enough, I think. And then 2 messy row entries, extra spaces, inconsistent email casing, and comma separated, right? And we're gonna have maybe string builder equals, not builder, we're gonna call it report maybe, new string builder, okay, and for each string s in entry in row entries, string TrimEnd entry equals entry dot trim, and then string fields TrimEnd entry dot split string name equals fields 0 int age int dot parse fields string email equals fields dot ToLower report dot append maybe name age email, and then maybe new line, right? Yep. And then just printing out console.writeLine report.toString. Yes, we use a string builder since we are appending inside a loop. For each entry, trim the white space, split on the comma, and grab each field, parse the age into an actual int, lowercase the email for consistency, and append a clean formatted line, right? So let's see the output. Alex 29, alexemail.com, Sam 34, and samemail.com. Trim, Split, ToLower, and StringBuilder all working together on genuinely messy, realistic input. This is honestly very close to real data cleaning code you'd write in an actual application. Okay, So your challenge for today would be taking a message string like john.smith at email.com. Let me show the example by writing. For example, your input would be something like that. Maybe john.smith email.com. Okay, you should trim it lowercase and use split to separate username from the domain based on the @ symbol, and print both parts separately, and use the string interpolation with the format specifier to also print today's practice score as a percentage using any number you like. Okay, so today we covered a genuinely huge toolbox to upper, to lower, trim, substring, replace, split, and join. Contains and also index of, starts with, ends with, proper string comparisons, format specifiers with interpolation, and finish it with StringBuilder for efficient string building in loops. Strings are something you'll work within literally every single program you ever write, so these methods are genuinely worth having comfortable muscle memory familiarity with, right? Next time we are moving into dates and time, working with date time, time span, and formatting dates properly. See you there. Take care.